Hello, my wonderful calculus students, and welcome to Unit 4, Day 7, Applications of the Derivative, things to do. I can't formulate thoughts right now. So today we're going to kind of pull in everything that we've kind of done over the last few days, but we're going to be doing this in the context of particle motion. And so in the past few lectures, we've been looking at increasing and decreasing intervals, concave up, concave down intervals, inflection points, extrema. We've done EVT, MVT, all those things. Okay, and now we're just going to kind of pull those ideas together and look at how they relate when it comes to problems dealing with the motion of a particle, because that's the most common application of derivatives is with physics and particle motion. So we're just going to kind of review some facts dealing with particle motion, and then honestly, team, we're just going to do a ton of practice problems with particle motion. Okay, so here's what I want us to do. I want you to, as per the usual, go ahead and just pause the video and look at these statements that are there, these 15 statements, and see which ones you can figure out. So looking at these, fill in the blanks. What do you already know? Now, when we're talking about an object moving along a coordinate line so that we know its position, we're going to call that position one of two things in our calculus, where we're either going to call it s of t, and we usually use s as the name of the function if the particle is moving vertically, okay, or diagonally. If the particle is moving horizontally, we usually let the function be called x, because that's like the horizontal axis, as a function of time. Okay, so go ahead and pause the video, and let's see how many blanks you can come up with. Okay, so let's go through these first blanks. Initially, okay, the word initially, when you see that in a problem, means that time is 0. Okay, so if I ask you to find the initial position or the initial velocity, that means that time is 0. If the particle says it's at the origin, that means the position is 0. If it says the particle is at rest, it means the velocity is 0. Okay. Now, if the velocity of the particle is positive, what does that tell us about the particle? It tells us that the particle is moving forward or to the right. So I'll say forward or to the right. Okay. If the velocity of the particle is negative, then the particle is moving backwards or to the left. Okay, that should sound a little bit like increasing, decreasing, because it's really the same thing. In order for a particle to change direction, the velocity must change sign. So velocity is speed with direction. The sign of the velocity indicates direction. Okay, now this is one you probably didn't know. The displacement, okay, so that's a vocab word, that's the letter E, is the change in position from A to B, and can be found by doing S of B minus S of A if your position is called X or S, and X of B minus X of A if your position is called X. Okay, it's just final position minus starting position. It gives you the change in position. All right, 7 down. Let's see what else we got. To find the average velocity over a time interval. Now, this is really important, team. The average velocity in a time interval. The average velocity is saying what is the average rate of position. So we're going to divide the change in position by the change in time. Okay. It is not the change in velocity over time. It is the change in position over time. So that would just be x of b minus x of a over b minus a. Okay, that's the letter x. There we go. Okay, instantaneous velocity is the derivative of position. So average velocity is the change in position over time. Instantaneous velocity is the derivative of position. Now the speed of an object, okay, if I ask for the speed, it's the absolute value of velocity. Okay, so we say that speed, and we don't use the letter S for speed because that means position in our world. We say speed is the absolute value of velocity. Okay, and here I can say that velocity, which I usually use V as the letter, is the derivative of position. So writing the same sentences in symbolism. All right, let's keep going. The rate of change of velocity is called acceleration. And I'm talking about the instantaneous, so we usually use the letter A of t, and that's just going to equal v prime of t. The average acceleration, aka the average rate of change of velocity, is the change in velocity over time. So we would do v of b minus v of a. So the rate of change of velocity is the average acceleration. Okay, that gets really confusing later on, so we're just going to keep that straight. If the acceleration is positive, then the velocity is increasing. If the acceleration of the particle is negative, then the velocity is decreasing. So we're still just doing our little f prime, f double prime chart. We're just doing it in the context of a situation. Now this last one, an object is speeding up. Now this gets really confusing for people to justify if an object is speeding up versus slowing down, because we just want to look at whether the acceleration is positive or negative. But the acceleration, guys, if you're talking about speeding up, you have to think about the speed graph, not the velocity graph. And the acceleration is the derivative of velocity, which is, that graph is a little bit different than the speed graph. So let me show you what I mean. Okay. If this is my velocity graph, okay, then this is my speed graph. Now, if I'm talking about speeding up, okay, speeding up means that my speed is increasing, which would happen right here and right here. So notice the slope on the speed graph is positive in that value. Now, if we look at the original velocity graph, which would be the function we have, the speeding up parts that are the same would be right here and right here, okay, because that negative velocity was moving in the negative direction, and so when I flipped it, it ended up going positive. Okay, so let's look at this. So we're speeding up if we have a velocity function and not a speed function, which 99% of the time we have a velocity function. We know the object is speeding up if it has a positive slope on the positive side or a negative slope on the negative side. Okay, so anytime the velocity graph is moving away from the horizontal axis, that's when that function is going to be speeding up. So to prove that, I just have to look at the signs. If velocity is positive, okay, I'm just going to put v of t, and acceleration is positive, then my particle is speeding up. Likewise, if velocity is negative and the acceleration is negative, okay, then we are also speeding up. So anytime velocity and acceleration have the same sign at that value of t, then we would say the object is speeding up. If they had opposite signs, it would be slowing down. So what we're going to do is we're going to take these like kind of key words and key things that we look for with the stuff that we've done before, and we're going to try some problems to solve. So we're going to try some free response problems, actually, some calculator and non-calculator questions. So let's just get our brains warmed up with number one. I want you to go ahead and read the question. Hit the little pause button in the video. Okay, try it on your own, and then unpause me and I'll go over it. Okay, a projectile is shot upward from the surface of the Earth and reaches a height of that function in meters after t seconds. I always underline this, guys. Find the velocity at 5 seconds. Okay, so this is just to get your brain whirling. I have a position. Notice that the positions function is called s of t because we're going up and down. Okay, and I want the velocity at 5. So I think, how is velocity related to position? Velocity is the derivative of position. So to find velocity, I'm going to take the derivative of that function. Okay, and then I want to find the velocity at 5 seconds. So I'm just going to plug in 5 for t. And that gives me 71, I think. And then my units would be position is measured in meters, time is measured in seconds, so velocity would be meters per second since it's a rate of change. Okay. All right, now we're going to be doing some non-calculator free response practice and some calculator free response practice, and we're going to be doing it with all the different representations of functions. So number 1 was kind of an algebraic one, starting you off. Number 2, we're going to do a numerical representation. 3, we'll do a graphical representation. 4, we'll do an algebraic full free response. And then number 5, I'll show you how to deal with it with the calculator. Okay. Each of these problems should take you about 10 to 15 minutes, depending. So if you're pausing me to try them on your own, it should take you about 10 to 15 minutes to try these problems, and then unpause me for the solutions. Okay, so the data in the table gives selected values for the velocity in meters per minute of a particle moving along the x-axis. So I just kind of like make a note of this. This is like tells me if I'm going right and left. The velocity is a differentiable function of time. Ooh, that's good. They tell me that information. At t equals 0, is the particle moving to the right or the left? Explain your answer. Okay, so if I have a velocity graph, okay, I know it's differentiable, which also means it's continuous. And I'm trying to figure out, is it moving to the right or to the left? Now, if I have velocity and it's talking about moving right or left, I'm going to look at the sign. So I'm going to say it's moving left, okay, because v of 0 is -3, which is less than 0. And guys, that's like my whole explanation here. I'm not doing anything else. I'm not writing a whole paragraph. I'm just saying left because the velocity is negative. Is there a time during the time interval 0 to 12 minutes when the particle is at rest? Okay, so I have to think, what does at rest mean? At rest means the velocity is 0. So is there a time during the 0 to 12 interval where the particle is at rest? Okay, if they are giving you, is there a time? This is your like, hello, this is my clue, okay? They're asking me to identify a theorem. So if they're asking me to figure out if the velocity is at 0 and I have a velocity function, first I'm going to think about what theorem they're trying to get me to use, which if they're talking about the values of a function, that's either going to be EVT or IVT. Now, if they're talking about a specific value, then that would have to be IVT. If they're talking about an extreme value, that would have to be EVT. So they're testing me on IVT. So if I look at here and I want to think if the velocity is at rest, I have to find 2 points where 0 is between those 2 points, which would happen here. Now, the fact that I know this has to be true is because they told me in the story that velocity is differentiable, which implies that velocity is continuous. So here's how I'm going to write this. I'm going to say yes, okay, between 0 and 2 seconds. Or no, 2 minutes, sorry. Okay. Since v of t is differentiable, v of t must be continuous. On 0 to 12. Okay. So that's the kind of the first part. Because v of 0 is less than 0, which is less than v of 2. Okay. there is a time where V of t equals 0. And now that would get me full credit, team, for my answer. Notice that I used IVT, but I didn't say IVT at all because I said this, okay? That is what you need to say. Now, if you want to say by IVT, just to kind of be like, I know, I want you to know I know the theorem's name, then you can as well. Okay. All right, C. All right, where'd it go? Wait, where's my C at? Oh, I think it got erased. Dang, team. Oh, no, there it is. Okay. Use the data from the table to approximate V prime of t and explain the meaning in terms of the motion of the particle. Show the computations that lead to your answer. Indicate units of measure. Okay, this is a key thing that they're going to be grading your units. Show the computation just means show the setup. And this problem we've done a million times. So if I want to estimate V prime of t, okay, that would be the derivative of velocity. And since I have a table, all I can do is use an AROC to estimate the IROC. So I'm going to do V of 12 minus V of 8 over 12 minus 8. Now, why did I pick 12 and 8? Because 10 is between 12 and 8. Okay, so when I do that, that counts as my computations. Now, if I want to go straight to 5 minus 7 over 4, that would also count as my computations. And then my answer would be negative 2/4 or negative 1/2. And now I need to think about my units. So let's think about what we did here. The velocity was measured in meters per minute. The time was measured in minutes. So that's actually going to give me meters per minute squared. So always look at your fraction and put the units of the top on top and the units of the bottom on bottom to get your units of your rate. Now, what did we just find? Okay, we actually found the average, the estimate for an acceleration. But when I write it, I'm going to say at 10 minutes, okay, you got to mention the time, the velocity, because that's what we had a table of, is decreasing or changing at a rate of 1/2 meters per minute squared. Now you can also say the acceleration is approximately. That also works. Okay, let A of t denote the acceleration of the particle. Is there guaranteed, that's bad grammar, is there guaranteed to be a time t equals c such that A of c is 0? Okay, is there a time? That is a theorem question. Now, which theorem are we using? That's what you have to figure out. So let's go back to what the table is of. The table is of velocity, and they're asking me about an acceleration value. So this is not IVT because it's not the values of the function that I've been given. Okay, IVT would be talking about the function given. EVT would be talking about the function given. MVT would be talking about the slope of the function. Now, if I know my function is velocity that I'm starting with, they're asking me about acceleration. Acceleration is the slope or the derivative of velocity. So really they're asking me, is there a slope equal to 0? So is there a time where V prime of C equals 0? Now, anytime we're trying to guarantee a slope, that, my loves, is MVT. Okay, so let's go back and think about what MVT says. It's the guaranteed slope theorem. It says the slopes that we can guarantee are the slopes that are the same as AROC. So whatever there is an AROC equal to a number, then the IROC has to equal to a number as long as the function is continuous and differentiable. Okay, so let's look back at our table. We'll go back. If I look at this table, I'm trying to think, is there a time where the slope would be 0? Okay, to show that, I would need to find 2 points where if I found the slope between those 2 points, the slope between those 2 points would be 0. That would be an AROC. Okay, if I can show that there's an AROC of 0, then I can show that there's an IROC of 0. Now, a lot of people just want to go 0 to 12. So if I go 0 to 12, the slope between those 2 points is 8 over 12. That's not 0. I'm trying to find 2 points. Now, it can be an interval within an interval as long as it's somewhere between 0 and 12. So if I focus on these and I look between 6 and 12, notice how the velocity values are both 5. If I found the slope between those 2 points, I would get 0 over 6, which is 0. So the average rate of change between 6 and 12 is 0, which means there has to be an instantaneous rate of change of 0 somewhere in there. And since 6 and 12 is between 0 and 12, it works in our situation. Okay, so here's how we're going to say this. We're going to say v of 12 minus v of 6 over 12 minus 6 equals 0 meters per minute squared. Okay, so that's like my work, the algebraic or numeric proof. So then I'm going to say, yes, between 6 and 12. Since v of t is continuous on 6 to 12 and differentiable on 6 to 12, and the average acceleration equals 0, there must be a time where a of t equals 0. Now again, I didn't say because of mean value theorem. It's not because of mean value theorem. It's because the function is continuous and differentiable. Now, if you want to say by MVT, then you can say that, but that is not the reason why. Okay, so there's your first table practice. Now let's try a graph practice problem. So now we're going to be given a graph, which is kind of like what we've done. Again, all the same stuff we're doing again, we're just doing it in the context of these situations. So the graph below represents the velocity. Okay, I like to make it real known that I'm looking at velocity in feet per second. At t equals 4 is the particle moving to the right or to the left. Okay, so go ahead and pause me and try this problem, and then unpause me and go through the solution with me. Again, you want to do some thinking on your own, so don't just let me like walk you through the problem, because then that's when you think you understand it, and then you get to your homework and you're like, I have no clue. So you have to do some thought on your own, and then when you get confused, we can go through it. Okay, welcome back from that pause that you definitely did. Okay, at t equals 4 is the particle moving to the right or to the left. So if I look at 4, again, I'm thinking to myself, I have velocity. What does that tell me? Well, if the particle is moving to the right, the velocity is positive, left, the velocity is negative. So at 4, I can see that v of 4 is like 1 to 6, which is greater than 0. So I'm going to say right, because v of 4 is greater than 0. There we go. That's all I got to say. Over what time is the interval? Over what time interval is the particle moving to the left, aka when is the velocity negative? I'm going to say from 5 to 9. And since 9 ends at a negative value, I'm going to include it. And I'm going to say because velocity is negative. At t equals 4 is the acceleration positive or negative? Okay, so I'm looking at velocity. They're asking me about acceleration. What's the relationship? Acceleration is the rate of change or slope. So if I look at 4, the slope of the velocity graph is negative. So I'm going to say a of 4 is negative because velocity is decreasing. Okay, over what time interval is the particle speeding up? Okay, now for speeding up and slowing down, we have to look at what time does velocity and acceleration have the same sign. Okay, so when is the velocity graph basically moving away from the x-axis? So I'm going to say 0 to 3 and 5 to 6. And that's again because, okay, because v of t and a of t have the same sign. Okay, let's try another one. What is the average acceleration of the particle in the interval 2 to 4? So the average acceleration. So again, I have velocity. They're asking me about acceleration, and that's going to be a slope. So they're saying, what's the average slope between 2 and 4? So I'm going to find v of 4 minus v of 2 over 4 minus 2. So the rate of change of velocity is acceleration. And then, so v of 4 is 6. Yeah, v of 4 is 6. V of 2 is 9 over 2, which gives me negative 3 over 2. And now I have to indicate units. Okay, so what did I measure velocity in? Feet per second. Over time, which is in seconds. So that actually gives me negative 3 over 2 feet per second squared if I simplify those units. Okay. And again, if they say indicate units of measure, it means they're grading your units of measure. Okay, is there guaranteed, theorem time, such that v prime of t equals negative 3/2? Okay, so this is asking, is there guaranteed to be a time in the interval 2 to 4 where we have to have a slope equal to negative 3/2? So is there a guarantee? In other words, does one of my theorems apply? Now, if they're talking about the slope, okay, then they're talking about MVT. So does MVT apply in the situation? And the answer is no, because V of t is not differentiable. Now, did we find a slope equal to negative 3/2? Yes, we did. Okay, but is it guaranteed? No, it just happened to happen. Okay, so it's not differentiable on 2 to 4. Okay, so just because it happens doesn't mean it was guaranteed to, which is kind of coincidence. Okay, so there is your graphical example. All right, let's do another one because we're guaranteed to have one of these on the AP exam. So whether it's a graph, a table, or algebra, or a calculator question, we have to be ready for anything, and that's kind of where we're practicing them all today. So a particle moves along the x-axis so that at time t, its position is given by this function. Initially, there's that key word, is the particle moving to the right or to the left? So I have to think about initially means time equals 0. And if we're talking about moving to the right or to the left, we're talking about velocity sign. Okay, which means if I want to figure out where the function is moving initially, which way, I need to find the velocity. So I'm going to say, all right, my velocity is my derivative of position. That earns me a point knowing the relationship, which is 3t squared minus 12t plus 9. Okay, so now I'm going to figure out what's the velocity initially. So at time 0, I get 0 minus 0 plus 9, which is 9. So if I look at that initial velocity, because it is positive, we know the particle is moving to the right. So I'm going to say right because v of 0 is greater than 0. Look at that little explanation. Okay. At t equal to 1, is the velocity of the particle increasing or decreasing? So this question is different than is the particle moving to the right or to the left. We want to know, is the velocity increasing or decreasing? Okay, so the velocity is increasing if its slope is positive or negative, which means I'm going to have to find the acceleration here. So that would be 6t minus 12. Okay, so if I figure out what the acceleration is at 1, I would have 6 minus 12, which is negative 6, okay, which is less than 0. So what does that tell me? The velocity is decreasing because a of 1 is less than 0. Now, if I asked you if the particle is speeding up or slowing down at 1, that is a different question. We would have to figure out what the acceleration is and what the velocity is. So I would have to plug in 1 into my velocity equation to figure out if I'm speeding up or slowing down and compare it to the acceleration. Okay, let's keep on grinding, team. Find all values of t for which the particle is moving to the left. Okay, so if I want to figure out when my particle is moving to the left, I'm trying to figure out where my velocity is negative. Now, to do that, I would need to figure out, well, let's analyze my velocity, my position function by looking at which way it's moving when. That's going to be where the velocity is positive or negative. So in other words, I'm trying to figure out where the function is decreasing, so I'm going to follow that procedure. I'm going to take the derivative, which is the velocity, and set it equal to 0 to find my critical points. Those are going to give me, in this situation, the at-rest moments. So when the particle is not moving is what it would find. Okay, so if I solve that, I'm going to factor out a 3. I'm going to factor this little baby quadratic. And I'm going to get t equals 1 and 3. Okay, so now what I'm going to do is I'm going to figure out a sign chart for my velocity. Now my sign chart, guys, I'm going to cap it because time can't be negative. So I'm going to say 0, and then I'm going to put 1 and 3 are my 0 velocities. So now let's figure out what happens in between them. Use the factored form to test. It's easier. If I plug in 0.5, 0.5 minus 1 negative, 0.5 minus 3 negative times a positive is a positive. If I plug in 2, positive, positive, negative, negative. If I plug in 10, positive. So where is the velocity? Where's the particle moving left? Okay, it's moving left from 1 to 3 because v of t is negative. Okay, well on our way to getting a 9 out of 9 on this free response. Okay, find the displacement of the particle over the time interval 0 to 5. So when I see displacement, I'm thinking change in position. Okay, final position minus initial position. So I'm going to go ahead and plug in 0 into the original function, and that's going to give me 11. If I plug in 5, okay, well that's like 5 cubed minus 6 times 5 squared plus 9 times 5 plus 11. That's going to equal 31, I think. And then from there, I'm going to do x of 5 minus x of 0 is going to equal 31 minus 11, which is 20 feet. So the change in position is 20 feet. Now, here comes some confusing things. Find the average velocity. So the average velocity from 0 to 5 is the average rate of change of position. So to find the average velocity, I'm going to say, okay, what is my change in position over the change in time? Now, team, we just found that change in position. It's 20. Over time 5 gives me 4 feet per second. Okay, find the average acceleration of the particle over 0 to 5. That's going to be the change in velocity over time, would give me acceleration. Okay, so I'm actually going to have to plug in 5 and 0 into my velocity function. So just to recap, the velocity function was 3t squared minus 12t plus 9. Okay, so I'm going to plug in 0. I'm going to get out 9. If I plug in 5, I'm going to get out 75 minus 60 plus 9, which is 15 plus 9, 24. Okay, so I end up getting 24 minus 9 over 5. That's just 15 over 5, which is 3 feet per second per second. Okay, and there is your algebra example. So it's just a matter of like, what do I have and what are they asking me for, and kind of going through each one. Now, the last thing I want to do is kind of go through a calculator question with you. Okay, now I don't have a calculator to show you, so I'm going to try to tell you what to do, and I want you to follow along in your calculator the best you can, and I'm going to write down the commands because I don't have the TI Smart View and it's super annoying. Okay. I also highly recommend using Desmos, but on the AP exam, you're going to have to use your TI, so you need to start practicing using your TI. Okay, so we're going to do this last one, and then we'll call it a day because it has a lot of problems that Ms. Bowman has done at 5:30 in the morning on December 10th. Okay, so if we are going through and doing this problem, a particle moves along the x-axis for 0 to 6. Okay, so it doesn't give me the domain. The velocity of particle is given by v of t equals 4 plus blah, 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 blah. At t equals 0, the particle is at the origin. Okay, so I'm going to underline all those. So it gives me a point of the particle, it gives me a domain, and it gives me a function for velocity. So here's what you're going to do first. You're going to go into your calculator, and you're going to graph that function in the graph. Okay. So I'm going to be doing this in Desmos at the same time because I do not have my calculator at home. Yay, pandemic. Okay. All right. Now, the other thing, before you hit graph, it does give you a domain. Set your window. Okay, set the scale on your window. So your x min should be 0, your x max should be 6, your x scale should just be 1. Okay, and then hit graph and make sure that you can see the whole picture. So you might have to play around with the heights a little bit and that kind of stuff, but you just want to make sure that your window is the same as their window so that you don't look outside of it. And I'm going to go ahead and try to get my picture. Okay, we're all ready. Now, find all the values of t on 0 to 6. Now, let me tell you, my loves, on the calculator section of the AP exam, okay, there is no algebra work. You should be doing nothing algebraically, okay? So what you're going to do is you're going to do everything using the calculator, and all we're going to do is write setup and answer, setup and answer, setup, answer, and explanation. Okay, so we should be doing nothing by hand, and they're going to give you the stupidest looking functions for that reason. They don't want you to take a derivative by hand of that. That'd be a nightmare. Okay, so find all values of t in the interval 0 to 6 for which the speed is 5. Okay, so I'm going to write what that means. Speed is the absolute value of velocity. So I'm looking for where the absolute value of velocity is equal to 5. Okay, well, how am I going to do this in the calculator? Well, hopefully you're seeing that your picture looks something like this. Okay. Depending on how you scaled it. Okay. I think I have my scale up here to 15, and this scale is -20, something like that. Okay, so if I'm trying to find when the speed is 5, I'm trying to figure out where is the velocity equal to 5, or where is the velocity equal to -5. So here's how you're going to do that, guys. You are going to take your y equals, and you're going to put in the equation y equals 5. Okay, so everybody in their calculator go to y2 and graph y equals 5. Okay. Now, this is going to give me when the velocity is equal to 5. So what I'm going to do for that one is I have a graph. I'm going to find the points of intersection of that graph. So I'm going to go to second, calculate intersect. Okay, and then it's going to ask me some questions. What's the first equation? What's the second equation? What's your guess? Now, a guess team, you can either scroll your little blinking dot close to it, or you can type a guess. So if I look down at my x-axis, I might type a guess. I might say 0.5 and hit enter, and then it'll give it to me. Now, do pay attention that there are 3 intersection points. So we're going to say 0 is the first one. Then if you find the next one, go ahead and try to find it. Pause me and find it. Okay. Unpause me. You should have gotten 0.344, always 3 decimal places. And then this one over here, okay, go ahead and find that one by doing second, calculate, intersect again. It's going to ask you questions. What's the y1 equation? What's the y2 equation? What's your guess? And when you do that, you should get 2.575, I believe. I'm doing this on Desmos at the same time, but I think that's what I got. Okay. Actually, let me check. Yep. Okay. Now, that would only earn you 1 out of 2 points. The other key thing here is that we also have to consider when the velocity is -5. So now go back into your y equals and take out the y equals 5 and replace it with y equals -5. I do it one at a time. Otherwise, it gets kind of confusing. So now what you're going to do is graph y equals -5 and find that point of intersection right here. I'll give you a second to do that. Pause if you need me. You always get that space bar pause. Okay, 4.753 is what I got. Okay, so this question would be 2 points. 1 point for your setup and then 1 point for your answer. Notice I did nothing algebraically, right, team? I put the setup there, I let the calculator do the work, and I wrote the answers to 3 decimal places. This is going to be the theme of this problem. It's the best one because you don't have to write any work, which is going to bother some of you, okay? But others of you, you're going to be like, yes, finally. Okay, part B, what is the acceleration of the particle at 1? Okay, now, acceleration, we have to think. We have velocity. Acceleration is the derivative of velocity. So what I'm trying to find, okay, is if I want the acceleration at 1, I'm trying to find v prime of 1. Now, there are 2 ways to do that. Since you are already in the graph, you can use the graph. So if you go to second and then the trace button for the calculate menu, you can go down to where it says dy dx and select it. Okay, then it's going to ask you to type in your x. So you're going to type 1 and then hit enter, and you should get the slope. Okay, the other way to do it is to get out of the graph and go math 8, which is the derivative, and then you need to fill in the blanks, d dx. And then here, you're just going to find the y1 command. The y1 command is in F4. So it's like alpha trace, I think, is F4. And you can find y1, and then it'd be at x equals 1. Now, make sure when you did type in this function that you put it in terms of x, right? Your calculator only understands x. It doesn't understand t. So you do that, and then you write down the answer. Okay, so if I were finding v prime of 1 here, I'm going to get 0.935, 3 decimal places. And then I'm done, team. Literally, that's all they want us to do. Okay, like, let's go on to part B. Find all the times in the t which the particle changes direction. So if I want the particle to change direction, okay, I have to think velocity changes sign. So v change sign. Okay, so now how am I going to let my calculator do this work for me? Well, let's go back to the fact that I have this graph. So here's my little velocity graph. I'm looking for where the velocity changes sign. So what I'm going to do first is figure out where is my velocity equal to 0. Hello, 1 point, just by writing that I'm looking for the zeros. Okay, that happens there. So then you're going to go to second calculate, so second trace, and we're going to choose 0, okay, which you did a lot of in math 4, or math 3, I think. So then it's going to ask you, what's left of your 0? Now, guys, you can either scroll to the left of this 0, or you can type a number. As long as it sets that little like arrow to the left of it, then you're going to be okay. So maybe you type the number 2. It's always faster to type. And then you type the number 6 to give you a window this way. As long as your 0 is between these 2 arrows at the top, it's going to find it for you. Now your guess, I'm going to guess 4 because that's what it looks like. That's why I always scale my window so that I know the x-axis, and it makes this part faster than having to go like right, enter, left, enter, back to it, enter. Okay, it's just faster for me to type numbers. And I'm going to say t is approximately 0. Oh wait, no, let's see. I believe, let's see what it is, 3.903. All right, I got 2 out of 3 points. I've done no algebra work. That's the whole point of this, team. Okay, now, justify my answer because v of t equals 0 and changes sign. There you go. There's a sign change. That's all I need. Okay, now, is the particle speeding up or slowing down at t equals 2? This is the question that most students miss, okay, that we're going to go ahead and find and get it right. So if I'm trying to figure out if the particle is speeding up or slowing down at 2. Okay, so I need to figure out then, okay, what is the acceleration at 2? And what is the velocity at 2? And do they have the same sign? Okay, now again, you're not doing any of this work algebraically. You're going to do all of this work in the calculator. Now to find a of 2, that's the slope. Remember, that's v prime of 2. If you're in the graph, go to second trace, second calculate, go down to number 6 where it says dy dx, choose that menu, type 2, hit enter, and you should get negative 1.297. And you could say 296 or 297, okay? Now, to find v of 2, if you're in the graph, okay, go to second, trace, second, and then hit trace, and then choose number 1 value, and then type 2, and hit enter. And that should give you the point at 2, and the point at 2 is 6.082. The AP exam is going to be actually looking for the value. So you can't just say it's positive. You have to give the numeric value there. Okay, now if you are in the non-graph screen, to get a of 2, you're going to go math 8. And that's going to give you d dx. You'll type the x there. In here, you're going to put y1, and then you're going to do x equals 2 and hit enter. Okay, to get v of 2, you're just going to do y1 of 2. So if you type that, and again, that y1 is under F4, if you type that and hit enter, it's going to automatically do function notation for you and give you 6.082. So now what can we conclude about this? Well, let's look at them. The velocity is positive, but the acceleration is negative. Therefore, the particle is speeding or slowing down. So slowing down because v of 2 is positive and a of 2 is negative. Okay, again, really look how much work I wrote. I wrote the 2 numbers and then I wrote the answer and I'm done. And I got a 9 out of 9 and I did no algebra, team. That's the whole point. Okay, so there's some practice for you. Have a great day and I'll see you next time.